What's up, everyone? This is LeetCode 150. So evaluate reverse Polish notation. So you can click here to understand what reverse Polish notation is, read all about it. I'm not going to. I assume you've already done that. So we're given an array of strings tokens that represents an arithmetic expression, and we have to just evaluate the expression, right? So here are some kind of notes that may help you in terms of how to handle the input, what you should expect, etc. Right, so the way this works is when we hit an operator, right, we have to take the two previous numbers and do something with it, right? So 2, 1 plus, right, that would be 2 plus 1. So that gives us 3. Then we have another 3 and we hit this operator here, which is multiplication. So this result here gives us 3, so 3 times 3 gives us 9, right? Here, right, 4, 13, 5. Division, so we have to divide 13 by 5. These are integers, so 13 divided by 5 gives us 2. Then we hit this plus and we get 4 plus 2, which should give us 6. And again, I'm not going to go through this one's a little bit longer, but I think this problem is a little bit easy, to be honest. I don't know, what's for me? I think from quite a few people, maybe, because it has kind of a high acceptance rate-ish. So, yeah. So, we're going to use a stack. I don't know if you can solve this problem without a stack. I definitely just use a stack, and it seems like it's the most optimal way to just handle this problem. The easiest approach is to use a stack. So we're gonna say for t in tokens, right? Let's iterate through this array, right? Now if t is plus or t is minus or t is this. Oops. Or t is division. Then let's handle this. Okay. If that's the case, right, if we have an operator, we need to pop from the stack and basically handle whatever operator we have, right? So we're going to say stack.pop, right? Answer is none. If that's not the case, by the way, we just have another number, then we just want to append that to our stack, right? Like, for example, if we're going through these tokens and we hit this 2, let's just append that to our stack so we can pop it whenever we hit this plus. Excuse me. So, for example, we have this 2 and this 1, right? When we hit this, and we add those to the stack, and when we hit this plus, we just pop these 2 from the stack so we can handle them, right? And the numbers are strings, right? So you need to actually convert them into integers. That's why we're doing this. Okay. Anyways, so if we encounter an operator, we need to pop from the stack, and let's actually handle whatever we have. So if t is plus, right? We're gonna say answer is s plus 1 plus s2. And then whatever we have as a result, we need to append that to the stack, right? So we're going to say answer append stack dot append answer. Else if t is minus, right? Minus, answer is going to be s2 minus s1. Because again, right? This is what gets popped first. This is what gets popped second. Right, look at this example here with 13 and 5. What gets popped second is what's first when we divide or subtract, right? Because when we divide or subtract, order actually matters, right? So that's why we have to do it like this. Don't do s1 minus 2. That's not going to give you the right answer. Okay, so we're going to say else if t is multiplication, we're just going to say answer is s2 or s1. It doesn't matter. Order doesn't really matter here. And then we need to do stack.append answer up here. I forgot to do that, right? Stack.append answer. Here is basically division. Okay. Now there is something important we have to do here, which is we need to do it a specific way. So you know, in Python you can do like S2 divided by S1 like this, or you can do S2 divided by S1. The problem with this, right? The problem with this is that this here truncates towards 0. And right here, it tells us we should truncate towards 0, right? So we obviously want to be using this one. This one here truncates towards negative infinity, right? Right? It truncates towards negative infinity. So for an example that I can give you, let's say we're doing 6 divided by 132, right? If we do like, if we do this, right? If we do this first version, this is actually just going to give us -1. Whereas if we do the second version, it should give us 0, right? Which is why you don't want to use this one, because it's going to truncate towards negative infinity, and we don't want that. It'll give you the wrong answer. Okay, so I just need to mention that it is rather important, so make sure you do this, and not this, okay? Because Python supports both, but they serve different purposes, depending on what you want to do, right? Yeah, I think that's it. And then at the end, when we do all this, all the reverse Polish notation, we're adding to the stack, right? So at the end, once we evaluate the whole expression, all we should be left with is one thing in the stack, which should be our final answer. So we're just going to do return.stackPop, and that should be it. Now, I've seen some people do like, if t is +1, right? Like, you see how I'm doing this twice here? The reason I'm doing this twice is because I only want to do, I want to just write stack.pop twice. Like, I don't want to write this in every single one of these. I mean, I'm just kind of lazy. And also, I mean, it doesn't really matter. Like, in either case, like, you're going to do it like this, right? And write stack.pop.once, or you're going to only write this once and do stack.pop in every single one of these. I mean, in either case, there's no way around it, but yeah, I mean, I think this answer is pretty readable, so I just prefer having it like this. But yeah, just a few edge cases that you gotta handle. This problem isn't too hard, so. And again, your like constraints really isn't that crazy either, so. At least as far as how big the integer range is, right? And we're in Python anyways, so even if integer range was a problem, you know, don't have to care that much about it in Python, but maybe in C++ you would, right? But anyways, I hope this helped, and I'll see you in the next one. Peace out.